Test, test. Okay, audio is working. Let me check whether PC audio is fine. Okay, it's not audible. Papa. Oh. Okay, I got an idea. And one. And it's not working. Why? Herb, give me a second. I'm trying to make you somehow audible. This one? And this one?
I'll explain what
Okay, you're going somewhere.
I mean by that.
Okay. Okay. Let's get back to the beginning. Okay, I'm a little bit stressed because it's my first watch along, and this is quite. I think I chose not an easy topic to be talking over, and I would want to avoid situation when I won't have anything to be said for a long period of time. Okay, maybe I'll just start. Wait, I just for the beginning. 2 hour long talk. Okay, I think we can manage that. In the worst case scenario, we'll do it in a few runs. Okay. Let's check if everything is just fine. Here. Okay, let's begin. Video title is. Maybe I'll put it somewhere. Let me try to. Wait. Did I froze? Yeah. Actually, yeah, Why? Hello, model, audio. Net. What happened? Yep. Yep. And I'm still frozen. Why? Why are you doing that to me? Yes, I am. I prepared my favorite blanket. Maybe I'll do something like that. And I put the name of the video below. Here. Ah, stop it. YouTube, could you even... Oops. Maybe a little bit lower. Here. Okay. So let's start again. You go there. And... Okay. Can C++ be 110,000?
I have a bit of a provocative title this year.
Wait.
But this is actually...
Caption. And large. Can C++ be 10 times simpler and safer? Probably not. For various of reasons. But please tell me, Mr. Sutter, what do you think about that?
a talk that I've been giving for 7 years in pieces. I'll explain what I mean by that.
7 years is... Wait, what was written here? Okay, in C++ there is a much smaller and cleaner language, struggling to get up. No, yeah, quite bold to say, Mr. Strausrup, given what you said after, yeah, these guys. This Secret Service said about security in C++. What was that? What was they? NSA, yeah. What NSA wrote. And what was your reaction? Say 10% of the size of C++ is in definition and similar in front-end compiler size. Most of the simplification would come from generalization. That's okay. We can. Okay, don't make forward opinions about that. That's just
I'll
what.
explain what I mean by that.
Hit me.
We are all here at CppCon and at conferences like it because we love C++. Maybe you feel as I do.
Yeah,
C++
that's
is the
harsh
best
love.
language in the world for me to write the software I need and want to have.
Depends on the reason and time, I think. C++ has a lot of challenges. The industry is doing lots of major C++ evolution experiments. This is one of these.
But C++ also has lots of challenges.
Yeah.
And so we're in a phase where we are seeing the industry doing lots of major C++ evolution and
That's
sometimes
true.
revolution experiments. This talk is one
I
of
agree.
those. So I want to be clear up front, and I'll try to repeat it often. This is my personal experiment. I am not speaking for any company. I'm not
Okay,
speaking
sure,
for the
that's
standards
fair.
committee. It's my noodling around that I'm sharing because I hope it'll start a conversation in a direction.
Oh yeah,
to make
we
C++
need the
better.
conversation.
But if anything comes of this, well, first of all, it's an experiment, so it can fail. That's the default for experiments. And
True.
if anything does come of it, I intend to continue bringing those as ISO C++ proposals, and you'll see I've already been doing that. I would like to encourage us, as a community of 7 million C++ developers around the world, as we consider C++'s future, to push the boundaries.
I
to bring
wonder
C++
how it is counted.
itself
Yeah,
forward,
probably
and
somehow
double down
statistical,
on
but
C++,
still.
not be quick to switch to something else. To aim for major C++ evolution, 10x major, directed toward things that will make us better C++ programmers, not programmers of something else. And there are lots of good experiments going on and products. Rust is a real product, not in production.
Yeah,
not an
Rust
experiment. And
is
there are other
very
experiments
pog.
on that side of the range.
It's
So to a greenfield
also
language design,
very
which is always fun to do,
ruthless language, but
new module systems, new packaging systems, building up their own new
it
ecosystem.
works just fine for what
Those
is
are valuable.
prepared for.
And we can learn from them.
What's the point? Greenfield language. After how long is Rust? It's not that young language anymore, I think. Okay, 8 years for the programming language is still quite young. Invent new idiom styles. Utilizes unknown for the community. In new modules, okay. New ecosystem packagers, okay. Compatibility bridges. I wonder what bridges means in this context. Okay, let's watch it.
But today I'm talking about the other end of the spectrum.
Refresh C++ itself, make C++ guidance default, make C++ modules default, keep C++ ecosystem packagers, keep C++ compatibility. I don't know about the last one. You know, I think the biggest issue now is this too strict trying. Maybe if it would be about C++ compatibility inside the C++, okay, full agree. But we really, I don't really think we still need this C compatibility. But yeah, let's give him
I am interested
room
in
to
refreshing
talk.
C++ itself, making the guidance we already have, the modules we already have, the default.
Okay.
Keeping our ecosystem, our package managers, our full compatibility, but making C++ better. So here's a roadmap of what we're going to talk about. I'm going to talk about the motivation.
Motivation approach. 50 times safer means 10 times simpler means okay.
The history that I've been working on this project for 7 years now, so this is a bit of a coming out party. But you'll see I've already been talking about it for 7 years. And we'll talk especially about safety and about simplicity examples. And I'm always going to talk about metrics. So when you see on the right-hand side of this title card, every time it comes up as the roadmap,
metrics to aim for.
Measurable progress. To me, safer, 50x safer means 98% fewer CVEs, vulnerability exploits.
Well, that's quite a challenge, but I hope it's achievable.
I can get rid of 90% of the paper of the books I teach today. That's what I'm aiming for. What could go wrong? So what is C++? That's a simplified version of a slide I showed here in 2018.
I see, yeah, maybe he's very optimistic about C++, but he can be critical. So plus for him, yeah, it's, I think I read 1 or 2 books written by him. So yeah, I know he's professional, and I'm really glad he comes from, you know, not this over-optimism, but quite critical. Can I move subtitles? I don't think so. Okay. And what is C++? Zero with the abstraction, determinism, and control, friction-free interop with C and C++. Okay. What is not core C++? Tedious syntax, tedium, specific syntax, tedium, lack of good defaults, sharp edges, unsafe code, vexing parsing, in general, not having nice things. Yeah, we all need nice things in our lives.
At CppCon, C++ is fundamentally about zero overhead abstraction. I always know where things are, how long they take, and friction-free interop, backward compatibility. That is core. But the rest of this stuff, I mean, some people seem to think, if it doesn't hurt a little, it's not really C++.
Okay, that's
I challenge that. And
interesting sentence to be said.
Specific syntax. We've been changing and adding syntax with every 3-year release.
Oh yeah. Oh yeah.
Security exploits. Those aren't core to the C++ experience. And we have been making those things better, but kind of like by 10% better-ish.
Right.
Every standard cycle. Not a game-changing 10x better. And the major reason for that, one major reason, is that we have strictly hewn to 100% syntax backward compatibility.
Oh, yeah, that's nailed the issue. The cake is not a lie.
What if we could have our cake and eat it too?
Men of culture.
And here is the strategy. The potential, if it works, judo move. You know our zero overhead principle we love so much?
Yeah.
What if we applied that to backward source compatibility? That
okay.
We always have backward 100% spin macros, give us all of it. Backward source compatibility available, but we only pay for it if we use it. Is that possible? So I'm going to ask you to indulge me for the next hour and a half.
Can say I understand.
Experiment backed by an implementation.
I mean, I understand what he said, but not understand.
What could we do if we had a second syntax for C++? One of the things that would give us, if it was a complete self-contained alternate syntax, had all the expressiveness, but spelled a different way than today, and it was unambiguous, that's a bubble of new code. You know what you have when you have a bubble of new code that doesn't exist today? Because nobody's written any code in the syntax yet today. You know what that means? You have exactly no backward source compatibility constraints. You can do anything you want that makes sense, that you feel is sensible, without worrying about breaking code, to reduce complexity, increase safety, improve toolability, and if it works out, to have a platform to build on to
being a little bit a point
for another 30 years. Remember when C++...
what if we could do C++ 11 feels like a new language again for the whole language? Okay.
C++ 11 came out, there was no question it was still C++, but some of it looked a little foreign and fresh, like, oh, smart pointers. Oh, the left to right trailing return type declaration syntax. Sure, we added stuff, but it was still C++. It felt like a new language. What if we could do that again for the whole language? That is what I've been working on primarily for the last 7 years. So in 2015, I spent a year in copious free time as a lower priority than all the other work to say, could we refactor C++? I didn't start with a blank sheet and invent a language. That's fun, but that's not what I was interested in.
2015, 16, basic language design, refactor C++ into fewer, simpler, composable general features. 16 plus, for individual parts as standalone proposals for syntax one flesh, each out in more detail, validate problem the committee wants to solve, validate it's a solution direction programmers might like for C++. Okay. Flesh out in more detail, validate it's a problem the committee wants to solve, validate it's a solution. Okay, makes sense.
I started with C++. What are the common pieces that may be spelled differently but could be unified? What are the pieces that we could refactor out so we have a smaller number of simpler, composable, general features that still let us express all the things we want to express? We're not dumbing it down. But the concept count is way lower. Because remember, concept
count is lower.
Is the number of things you have to teach. And it's not just the number of keywords in a language, it's also the number of exceptions. Anytime you have an irregularity, anytime you have two ways
things
to say
that we have already.
But when these two features work together, something different happens. There's another thing to teach and another thing to teach. And you know what you get with that linear list? Rote learning. Rote learning is hard. That's why we want to reduce concept count.
I think it's road as a, the same that vehicles are riding on. So I think this speech to text done goved.
But anything can look good on paper. So what I've been doing since 2016 is I've been taking one particular piece that could be disentangled, could be presented as a standalone proposal for ISO C++. And for the last 6 years, every conference talk I've given here and nearly every standards proposal paper I've written has come from the work I'm going to show you today, just in today's syntax.
Okay.
And the reason is to flesh each one out because you get that next level of scrutiny, so you find bugs and you can fix them. And also validate, is this even a problem that the committee and you, the community, want to solve? Do you think it's important? And even if that's true,
I believe it is.
Will you accept this solution direction, which is a separate question?
That's
all part of
interesting.
That there could be a there.
Problem.
And so all of the proposals and talks and papers down at the bottom have come from this work. I want to call out one in particular, Spaceship, because of all of these, that's the only one I presented and gave a paper without a prototype. And the reason is because I never actually had a talk about it here. I mentioned it for a few minutes in another talk. Because it was part of this design I'd been doing, but it was a target of opportunity where after C++ 17 shipped, suddenly the committee continued talking about comparisons, and it was clear that something was going to happen. So I thought, well, I have a design in my back pocket, let me propose it. But it didn't have a prototype. And because of that, it had two major bugs, which were fixed thanks to these people. So I want to acknowledge them. Some of them are here in the room. If your picture is on the screen, would you please stand up and wave both your arms so people can see you? Some of you are way at the back. Some of you are at the front.
That needs to be great feeling.
Thank you so much.
To be part of group that helps with such problem.
Many others help too. It's a large committee. This is the first piece of my simplification work that is part of the standard, and I think that's the right path to go. And I brag on Spaceship a little because it's the first feature we've ever added to C++, where yes, you added a dozen pages for the core language wording, but it made the standard smaller because we applied it in the library, and it reduced more than that many pages in the standard library. So I take that as some data that yes, simplifying can work. But now let's talk about the problem. I already talked about the problem of prototyping. The biggest thing that's been holding me back is it is expensive to prototype things in a production C++ compiler. Some of these have been my own little library, some have been done in Clang, some have been done in Visual Studio.
Because I spaced out a little bit. Dependent on prototyping in production C++ compilers. Okay, so maybe that's really interesting problem. How to? I would love to see all the procedure for bringing up a new feature. In a nutshell, because I think that's probably a really complex and long process. I would love to, I don't know, in an example, maybe he will touch it for a little bit.
But man, it's expensive to do.
I imagine.
So then I thought, as we all should, wait for it. What would Bjarne do? But not this Bjarne. Not this Bjarne. The other Bjarne in this picture.
Here? This one?
That Bjarne.
Okay.
It's a cardboard cutout, but the picture works, so I'm going to go with it.
Wait, give me a second. I need to fix a microphone because I'm afraid because I'm touching it too much. It can be can hit the quality of the audio, and I would avoid that problem. Yes. 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 Okay. Yes. Test. Okay. Test. 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 Okay. I don't know what happened. Let me try again. Test. 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 Okay.
Do. And the really nice thing about asking a question of what would somebody 40 years ago do is you could look it up on Wikipedia if they succeeded, and that's why we're all here. What Bjarne did is he built C-Front. It was a C++ compiler that emitted C code. And if you weren't around in the 80s, as many of us weren't in computing, you may forget that for the first decade of C++'s life, this was the C++ compiler, and C with classes, before it was even called C++. And Bjarne nailed three things. He nailed his value proposition, but he had a 15-second elevator speech.
Value, address key issue of C, lack of abstraction. Availability, usable anywhere, compatibility. If that worked for the time, and still works, let's be honest.
We love C. It's powerful, machine near, flexible, but it needs abstraction. I'm going to solve that problem. That's a succinct elevator pitch. And by compiling to C, it meant it was available wherever a C compiler was available, and you had full interoperability with C code, with C optimizers, linkers, debuggers, tools. Yeah, in the debugger you might see a mangled name for an overloaded function, but the debugger worked. This was powerful for C++'s early adoption. Without C-Front, we wouldn't be here. So my experiment
without C-Front, yeah, we all come from the water.
Is, could we do that again? And what I'm about to present is just my own experiment, my own personal code.
Oh, C++ front. Okay.
It is live on GitHub under hsutter. You can find it at CppFront. It is a syntax 2 to syntax 1 compiler in progress. But I have similar goals to Bjarne's. I love C++. Let's embrace C++ and double down on it, but address that it needs to be safer, simpler, and more toolable. Those are the problems we want to solve, but we still want it to be C++. And it works wherever a C++20 compiler is available. You'll see that in live demos today, and have full interoperability with today's C++. It should be C++, just nicer. Caveats, again, my personal experiment. Have I said that enough times now? This is a partial compiler.
Hilarious. To start a conversation about what could be possible within C++, solution to VTuberEN plus.
Hilariously incomplete. Over the winter, I hope to add classes. I mean, it's hilariously incomplete. Turns out
I would want to check this on the stream, but I'm not feel I'm prepared enough to do not mess around with showing browser, so I'll pass this time. But that's the thing I would want to fix to prepare better for showing whatever I can on the browser, in the browser, so we will check the project in real time.
you can get a lot of simplification just from functions. But my hope here is to start a conversation. Before we rush off to a different language, what could be possible within C++'s own evolution to rejuvenate C++? So here are the complete build instructions for CppFront. One line for
okay,
each
that's
major
not
compiler.
complex.
It builds and runs today on all major compilers.
I mean,
in
commands,
C++
yeah.
mode. When you write
C++20 and run.
this syntax 2, CPP2, I call it for short, which can be either a file that's all CPP2 syntax or that's interleaved with today's and syntax and the second one. Then just run it through CppFront, and then that will produce a CPP file, which you then just run through your compiler. So these are, the top half of this slide is the complete build instructions. There is no Bazel, there's no
maybe I'll be able somehow to pull up the code right now, because I'm really interested about what tries here. Would be the safest way. You know what? Maybe later I'll do some break and I'll prepare it somehow, because I don't have a good idea from the get-go.
CMake, there's no third-party library dependencies, there's no Yak or Bison, because I started with an empty editor and the standard library, and I never looked back so far. There's no third-party code. It's a custom-written manual parser.
Yeah, that's really interesting. He got my curiosity.
Let me just
refactor. Fewer composable general feature. Fewer composable. Be consistent. Don't make similar things different. Make important things visible. Be orthogonal. Avoid arbitrary coupling. Let features be used freely in combination. Be general. Don't restrict what is inherited. Don't arbitrarily restrict. Okay, it does make sense to, do not connect features strictly and make them as general as possible. And important difference visible. That's really important. All the programming all around. I feel people are not aware enough about that aspect.
Talk a little bit about an important principle and stakes in the ground. If you've been noticing those papers that I've been writing for the last 7 years, every single one of them in section 1 has this information on this slide and the next one, and how it applies to that paper. and please steal and reuse. Fred Brooks nailed it when he said the most important quality in a systems design is conceptual integrity, that it should hang together well, be as if the product
Okay,
of one
maybe
mind.
I'm ignorant, but I don't.
Fred Brooks nailed
Okay. Frederick Philip Brooks, American computer architect, software engineer, scientist, best known for managing the development of IBM 360 software support package, and then writing candidly about those experiences. Seminal book, The Mythical Man. I know about the book. I never read it. I plan to some moment, guys. Okay, so yeah, quite important person in business. Tab open after. Yeah, we are 15. Yeah.
it when he said the most important quality in a systems design is conceptual integrity, that it should hang together well, be as if the product of one mind, even if it's written by designed by a small team. So my goal is to refactor C++ into fewer composable general features, and that requires being consistent, orthogonal, general. And here are some examples of that. And if that sounds familiar, it's because it's exactly what Bjarne said that you saw in the walk-in slides as you were walking in the room. Bjarne has conjectured publicly for decades that within C++ there is a language 10% the size struggling to get out. The simplification would come from generalization, and my goal is to see if I can prove him right.
Okay, let's try.
So here are some stakes in the ground, some constraints. I am not interested in drive-by improvements. There are a lot of things I think I could improve about C++ that I tried and threw out because they didn't carry their weight. They didn't solve an existing problem. They were just a personal opinion. And I only want things that make C++ safer, simpler, and more toolable, and laser focus on those things. And to be measurable, to be able to quantify how much improvement we get in each of those. And of course, stay C++, our values, zero overhead, and that we can always take control.
Okay, yeah. I think that's a really cool approach to follow some personal ideas. I mean, this is personal idea, but to be more thoughtful about what is our problem to fix and what is general problem to fix, I think that's a really cool approach.
Visible, please do not make the mistake, please, and I know it's going to happen anyway, please don't make the mistake of saying, oh yeah, Herb gave a talk and he says he wants to make C++ prettier. It's not the point. That would not be interesting. It's fixing the semantics, changing defaults, removing special cases. That's the meat of it. The syntax is just to get us a bubble of new code. It's the gate into the new area. And yes, if you're going to build a gate, it should look good too. You should make it with good boards and give it good paint. But it's just the gate.
Oh,
let's talk
nice
about
gate is,
the gate, and
you
then
know,
we'll talk
nice.
semantics, which is the big payoff. Any language these days should be context-free parsing and order independent. You'll see examples of that. That's just table stakes for language design these days, I think. Also, as one language designer I know, declarations should be left to right, he said, this is quoting somebody else, as nature intended. Yes, so as with many things, Nicholas Wirth was right. And
yeah,
also I put a stake in the ground that declaration
nature
and
planned
syntax and expressions
to be everything left to right.
I'll write more about that later.
Japanese
in a later blog
probably
article.
don't agree.
So here are two examples of today's code. Class shape, that code, that class shape has been around since around 1980. Auto F int I arrow string has been around since 2011. And everything in those braces, we can't touch with breaking changes. We cannot change defaults. We would break the world. So I'm proposing a left to right syntax. So syntax 2, every declaration is name, colon, type, equals its value.
Let me. Syntax 2 code doesn't exist today. Can update semantics as desired without breaking change. Update semantics without. Okay, I guess he.
Shape is a type equal to this body. F is a function that takes an int and returns a string equal to this body. And variables the same. So here's an example. Main is a function that takes nothing and returns an int, and it's equal to this body.
Okay.
Vec is a...
That's quite a stretch, but yeah, functional way. Okay.
Stood vector, stood
like
string, notice the familiar terms, equal to this list of values, and so forth. And yes, we get ctag. Notice view is a stood span, not a stood span of string, equals vec, because this is still...
Out. View, grab the str.
C++, right?
Going by this.
Stood span of string, equals ctag. Notice view is a stood span, not a stood span of string.
I don't get.
Equal to this list of values. Stood vector, stood string, notice the familiar terms, equal to this list of values, and so forth. And yes, we get ctag. Notice view is a stood span, not a stood span of string, equals vec, because this is still C++, right?
Okay, so we are creating out of the vector.
So let's make this a whole program.
Right.
So one thing.
Oh, okay.
I want to
There
emphasize,
is rest of the code.
I'm showing this one slide program. This is a whole program that will compile and run, and there's not a single include or import. The reason is because in syntax 2, if you build a syntax 2 only translation unit source file, C++23 import std semicolon is default. You will never need to include and remember what header to include again. This is a modules first design. It is designed for fast builds, for strong ODR that modules only give you. And if you're worried about the build speed of bringing in the whole standard library, regex, parallelism, everything.
Yeah, that's my...
Import std on the current implementation is faster than include IOStream. It's faster to compile, to bring in import the whole standard library than to compile hello world.
Okay, that's interesting. I believe him without even checking because he's aeons before me. Or this is knowledge about programming, but that's a really interesting fact. I need to. You know what? I write it down.
to import the whole standard library than to compile hello world. My experiment is, let's make it the default. Hey, it's an experiment. If it doesn't work out, we can change it. We can tweak this. But I'm pretty confident about this one. You'll notice the parameters are passed the way I already told you about 2 years ago here at CppCon with my paper 708 parameter passing. So you'll see in out there. That's how parameters are passed. There are no references in CPP2, for example.
Okay, I guess in out is information about, that function. Differ input like an output. Okay. Wildcard implicit template.
Underscore is the wildcard, so those are implicit templates. If you had eagle eyes, you notice that that last function doesn't have squigglies around it. The reason it doesn't have braces is because one of the tenets I've embraced is there's one syntax for everything, but let's pick good defaults where, well, if you don't need certain parts, you just omit them. That's not two ways to say the same thing. That's one way to say the same thing with optional parts. If you don't need them, you don't use them. And for single expression or single statement functions, you don't need braces or the return statement if it's returning a value.
Yeah, that's fair.
And that's important because remember I said I have only one declaration syntax? I don't have a separate declaration syntax for lambdas. A lambda function is exactly, it's the same parse function.
That's
it is exactly writing a function at expression scope.
That's pretty right, it looks like a lambda.
And just omit the name. It starts with :paren.
Yeah, that's fair too.
One syntax for functions. And so for lambdas, it's really important that you can omit those because you want to write short lambdas conveniently. And by the way, did you notice that we called decorate and printline before they were declared and defined?
Oh, yeah.
There's no forward declarations. This is an order-independent syntax in language.
Yeah, that's usable. That would be really usable.
Here's the code that CPP front generates. And I want to emphasize, this is not PowerPoint. This is a screenshot. I'm showing the screenshot.
Oh, okay, because I was wondering what's the difference between, showing the screenshot in PowerPoint and else, but I assume he wanted to say he didn't copy-paste text, he simply... Okay, that makes sense.
Because I could do this as a demo, but demos take way longer. And I'll still do some demos, but I'm trying to save time. But try that program today when you get home, you'll get that generated output. This is a screenshot. And so let's see what's generated. So did you notice no discard is the default? How many of you wish no discard was a default? Yes, okay, good. Well,
approval from the
And remember, I'm writing this compiler, first of all, for me, for the code, to be able to write C++ in a more convenient way that I like. And I think that's the right choice. So that's why. When you write the compiler, you get to make choices.
Yeah,
that's... I have normal CTAD because I simply
makes sense.
I turn into syntax 1 code what you wrote as syntax 2. So stdspan view, that said view : stdspan equals vec. CTAD works just fine. How many of you noticed that I called thing.size on the previous slide? Anybody notice that? A few people. I'll bet they're all standards committee members who were in all of the signed, unsigned discussions.
Wait,
standards committees on the previous slide. Anybody? Fine. How many of you noticed that I called thing.size on the previous slide? Anybody notice that? A few people.
Okay, I noticed.
I'll bet they're all standards committee members who.
But what's about that? Let us check. Return thing that size. Yeah. Okay, let's continue.
You noticed that I called thing.size on the previous slide. Anybody notice that? A few people. I'll bet they're all standards committee members who were in all of the signed, unsigned discussions for years. And so where those all ended, to cut a long story short, is we did not Bjarne did not convince the committee to change all the dot size functions, for example, of all the containers to return signed. And he did not convince them to put a .s size on every container. He did get them to have a non-member s size function in namespace std. But because thing.size is a universal function call syntax in CPP2, it calls it just fine.
Oh, okay, I get
It'll
it.
use a member
So
if there is one, otherwise it will fall back. And I thought that was a small convenience. I've always been a fan of UFCS. Bjarne and I co-authored the papers about it,
okay,
8
I
years
don't
ago.
get it.
And others have written very good papers about it as well.
Wait, let me check
Members
again. Tell me.
You wrote a syntax too. So stdspan view, that said view : stdspan equals vec. CTAD works just fine. How many of you noticed that I called thing.size on the previous slide? Anybody notice that? A few people. I'll bet they're all standard.
Thing doing buying brackets doesn't turn the size of. So we are okay. I will. I have a hypothesis, but I want. What UFSC is? Form function call. Form function call syntax. Programming language that follows any called method call. By using the. Okay, so run this function over that. Later.
That CPP front generates, and I want it generated. To be able to write C++, that's why. So stdspan view, that said, how many of you noticed that I called thing.size on the previous slide? Anybody notice that? A few people. I'll bet they're all standards committee members who were in all of the signed, unsigned discussions for years. And so where those all ended, to cut a long story short, is Bjarne did not convince the committee to change all the dot size functions, for example, of all the containers to return signed. And he did not convince them to put a .s size on every container. He did get them to have a non-member s size function in namespace std. But because thing.size is a universal function call syntax in CPP2, it calls it just fine. It'll use a member if there is one, otherwise it will fall back. And I thought that was a small convenience. I've always been a fan of UFCS. Bjarne and I co-authored the papers about it, 8 years ago. And others have written very good papers about it as well. But I was surprised, as I was writing my dozens of examples and tests, I was surprised how quickly I just went to .s size and never looked back. Like, it's just so nice. And notice this does not, I hope, look like generated code. It is really important to me that if this experiment doesn't work, because it might not, experiments fail all the time, and that's the default, I want to be able to write code in this new syntax, and if it doesn't work out, not lose my investment, and always be able to just throw it away and walk away with my today's syntax code. That's important to me. And if we scroll up, here's how you get order independence. I don't order declarations for everything. In the place where you write a CPP2 function, I emit its forward declaration, intermixed with all the CPP1 code in the right relative places so it can call it as order dependently as CPP1 code is. And then I emit all the definitions for CPP2. And they're order independent, they can all see each other. Just to emphasize the readability, here's another example, which is a straw man example, A, B, C, D, E, F, G, H, I, J, K, L, little variable names. But to show you that to me, it's really important. This is
Side greeting goes here. That's sweet. Okay. But code first. Point arithmetic. And here we get this compiled array interp.
This is one of my test cases to make sure that I kept everything where it was when I emitted code, because it's really important to me that the generated code is not some glop, that it is beautiful in my personal style that I used in my CPP2 file. And so you'll notice a couple of things. I might have mentioned the declaration follows use. One of the consequences of that is most operators, including dereference, are postfix. It actually eliminates a lot of parens when you're using them. And so I rewrite those. You'll notice on the right-hand side, for instance, the D colon E call.
That's really cool.
And then put parens in the right places for star F as I rewrite the expression on the left, which changes the locations of things. And the universal function call syntax also changes the locations of things. But I stick close to what the original indentation was, including that I keep track of the locations of all comments and put them right back where I found them. That's really important to me. And if you run this with the -clean CPP1 switch, because when the day comes that I want to drop it and just walk away with my CPP1 code, I'll run it with -clean CPP1, and that's what I'll have. That emits the hash line directives and things like that. Because I want to never lose my investment. I want to have my today's C++ code all the time. That also keeps me honest. It helps me ensure that I'm sticking to C++. So everyone knows that generated code is ugly, right? Those are people who've seen foreign languages generated to C++.
Then
the worst
debug over them.
examples are when you have foreign concepts you're trying to shoehorn into a language that doesn't understand them. The ugliness of generated code is directly proportional to the impedance mismatch. If your source is still C++, then you can make it beautiful. So that's a litmus test for me. So would you like to see some live demos of a pre-alpha compiler?
I think it will be really helpful writing code to have this readable generated code instead of trying to figure out what author wants.
You just asked to see live demos of a homebrew pre-alpha experimental compiler. Wish me luck. And be kind.
Hey, everything will be fine.
I don't think it'll crash, but we'll see.
So
maybe. Our first example
happens to the best of us.
Is on the left-hand side. Notice this is a mixed file because I have include IOStream, include string, and I have a main line, which is today's syntax. This is normal C++ today. Yes, you can write auto main today. But I have these other two functions that I'm writing.
I didn't know that.
So I can show this in any compiler, any of the three major ones. So let me just, by applause, hear which one you want to see, Clang, GCC, or MSVC. How many would like to see me start with a demo with Clang? Okay. How many for
I want to see
Microsoft Visual C++?
See all of them.
That's about a tie. How many for GCC? Okay. It's GCC, which means I have to switch to my Ubuntu. Thank you, Windows, for having actual Linux. And so we'll go.
Yeah,
So we'll
I
go.
really like this
For some reason, it
Linux
is not taking keystrokes.
embedded in
Okay, let me
Windows
restart
WSL.
Ubuntu. Wow, this has never happened before.
Yeah.
Wow, well, this is really incredible. Well, I guess we're going to go to our second choice, which is Microsoft.
It always happens when you want to show someone
Honest,
something.
I've been doing this for months and months, and this has never happened. Okay, there must have been an update. Okay, let's see. Okay, good. This is taking keystrokes. So let's do CPP front demo.cpp2, and the first thing we get is an error because it's a live demo. But don't worry, this is an error I expected. So the first thing, you go through the first compiler, and it says, okay, great. It's mixed CPP1, CPP2. The CPP2 parts pass safety checks, okay? But then I get this error. What is it? So in demo CPP2, notice this error is coming from the second compiler, but it's in terms of my original CPP2 source file. Strin is not a member of STD, and if you were seeing this in Clang or GCC, it would say, did you mean string? So all the cool error messages we get today still work. And the reason is, if you look up here, I deliberately, mistakenly wrote strin, which is not a very useful type. So let's put back the G. And now,
Didn't he say that STD is by default?
And now it works.
Yeah, but in the end it
There's always a
doesn't
virus scan the first time you do an exe.
much if you deprecate.
Oh my, this is really incredible. There, second time was faster. See, there you go. So let's see what was generated. So starting at the top, here's our header with the utility functions that I need, including in parameters and things like that. Then I emit all the C++ syntax 1 code in order, and wherever I see a CPP2 definition, I emit the forward declaration in that order. That way, main can see decorate and name because CPP1 is order dependent, that's fine. But then I emit the definitions here at the end, including that I'll put braces around the decorate function body, things like that.
Okay.
So that's the
first example. So what we got here? Okay, I need to double check because I have my doubts about how this hash line works. Okay, directive sets the value of the line that immediately. Compiler uses preferred station. Line number refers to the current file name. Oh, okay, so it's to show the errors of the compiler here instead of here. Okay. Yeah, there is an example. Yeah, that's exactly what does. It moves the offset for the compiler for the underscore line underscore and underscore file underscore. Okay.
Example, just to show how interop works. You can interleave. You can't write CPP2 code in the middle of a CPP1 body or vice versa, but you can interleave them in the same source file. Have one function in one syntax, one function in another. So now let's see about a pure CPP2 file. Now, if I try to build this with, here, let me show you some of the switches. If I tried to build this with the pure CPP2 switch now, that wouldn't work. Why not? Well, let's just see. First thing it says is, no, CPP2, you don't get no preprocessor. You don't need no preprocessor.
Oh, yeah.
Yes, that includes include. Use import instead. Do you like that?
Okay, so that's the answer for the one of my questions here.
But let me just highlight a pattern you're going to see a lot. It tells you today's advice by default. Use the preprocessor less. And the thing it says to do instead is the thing we already teach people to do instead. In this case, as modules are coming online, import std. So let's actually make this code all CPP2. So here we go. We'll just replace this with a full CPP2 file. Then we'll build that.
Oh, okay, that's not the answer for my question. That's answer for another question.
Auto work. And there we go. Yes.
Okay.
So this time, all I did was change main to the new syntax. I just changed auto main to main colon, and I added an equals. That's the only difference. Plus, I moved it up here just because I could. And I dropped includes and imports just because I could. Because it's...
Oh, I think I didn't understood when he said first time. He meant not, avoiding namespace, simple. He probably you still need to declare name. Yeah, that makes sense to keep the namespace implicitly. Okay, I get it now. It's imports all std, but yeah, the syntax stays.
It's just order independent, and I always have the standard library as it should be. One last thing about this first demo is here I'm doing the normal good thing of putting a local variable on the stack. So I'm going to do something that's in bad form, but just to show you how the free store works. You shouldn't normally put a local variable on the free store, but just so you see how it works. S is a new string, new stood string. All allocation in CPP2 is done using named memory arenas, which are just variables, just objects that have a function called new, a template function called new.
Okay.
And I give you two of those by default. They're called unique.new, guess what it calls, and shared.new, guess what it calls. And I didn't say
I don't know.
Here, and so what's the default if you don't say the memory arena at all? What's global new? Unique new. So S is a unique pointer of string because unique pointer should be the default pointer. And this is totally type and memory safe code. And that's how I want it to be. Now, let me show you one thing about this, because we've been talking about the C++ standard library, but wouldn't it be nice if we gave the C standard library some love as well? Take a look at this code. Here I've got a C++ string, and I'm using a C fopen and fprintf to print the string using cstir, right? That should just work, right? So let's build that. And
okay.
Yeah, so that will print to my file, which is my dog Lily. So now if we do dir, there should be a file called dog. There it is.
Okay.
Yes, that's the timestamp we have now. So type dog, there's Lily. That's one of our dogs. She's really cute. She's an Italian greyhound.
Aww.
Did you notice anything odd about the left-hand side code? It's amazing how many people I show this to who don't notice I'm calling fprintf as a member function. How many of you did not notice that until I mentioned it?
Yeah.
Quite a few hands, because it's just natural, right? Now,
yeah.
Just being cute? No, it's about being more toolable. Because if you call using the non-member function call syntax, IntelliSense can't help you. If you start with an object that you have in scope, dot, now IntelliSense can help you with autocomplete and tell you all the things you can do with that object. If you're just starting a new blank line, IntelliSense can't do a thing for you.
Interesting.
And that's important for toolability. So UFCS is more than just convenient, it's about toolability. So for those of you who want to see these demos, I've captured some screenshots here of everything that we just saw, and you can take a look at those in the slide handouts. But the key here is, don't pay for what you don't use, being applied to backward source compatibility. You saw examples where I had mixed C++ syntax 1 and syntax 2. I included
syntax 1 and 2 in the same source file incremental adoption. Write one line and start seeing benefit. Can Braille A. Write one line and start seeing benefit. You got perfect source compatibility macros as Fine. One talk said that that's not probably good pronunciation, but presenters said that he likes it because it sounds sophisticated, so I saying Espina as well. Should include. Yeah, write Python 2.3 problem. I think, yeah, this used to be a problem like 5 years ago. And I think we are all cool, except few people few projects that for some reason stayed with Python 2, but okay, let's say a problem.
Stream, and that was groovy. It worked fine. Include string, use main with today's syntax, and it can call the new functions. It's all just fine. That is really important for adoptability. Remember, this is what Bjarne had. Bjarne and TypeScript are two excellent examples of this. Bjarne said, take any .c file you have.
I love it, like every time there is Bjarne mentioned, there's speak-to-text engine shows it differently.
Well, he also messed with the C language while he was at it, and improved it. But take any .c file you have, rename it to .cpp, and it will work. And that's largely still true today. And you can start writing one line of C++ code, one class, and start seeing benefit. Oh, this little bit is now encapsulated. That's a great adoption ramp. TypeScript did the same thing. Rename any .js to .ts, and it works. And you can write one line of TypeScript to add type information and start seeing benefit. That's what you can do here.
Test. Okay, something happened with the microphone. I don't know what. It freezes randomly. You know what? Maybe I'll change configuration. Change. Test. Okay, I'll keep it like that because it freezes randomly for some reason, and I don't know why.
You can rename any .cpp to .cpp2.
Okay, let's continue.
One line of syntax 2 and see what you think. In this mode, you have 100% perfect source compatibility with Spine, macros, all of it. And we've avoided the Python 2.3 problem because it's a unique and distinct syntax. But there's another way you can use it, which is a source file that's only CPP2. Then you get to program, I hope, if the experiment succeeds, I hope that I get to program in a C++ that's 10x simpler and safer and more toolable, that's safe by construction, that still has seamless interop with all of today's C++ libraries through module import, not the preprocessor, and I can stop teaching 90% of what I personally have been teaching people for the last quarter century
Okay.
of my life.
Right now, I'm the most interesting about the all
Because
security potential issues because he didn't mention how he would beat that. Because that's one of my biggest issue with C compatibility.
I want to teach people how to program, not how to incant a C++ detail. So let's talk about safety. I'm going to hit type, bounds, lifetime, and initialization safety. I'm also interested in other safeties, like emergency safety, but why these
Sorry for interrupting with testing, but I wasn't aware that microphone freezes randomly and I like to avoid it. So I'm checking it every now and then. But I think we should okay, I shouldn't start with this talk because we are not even in the half. So, okay, speed run.
They're still playing the hits. If you look at MITRE's 2022 Most Dangerous Software Weaknesses, and thank you for Dave Abrahams for reminding me to look at this. Thank you, Dave. Out of bounds write, out of bounds read, use after free, null pointer deref, and just when you thought that there was something other than type, bounds, lifetime, and initialization safety, integer overflow, that's different. No, it's not, because the integers you most care about overflowing are indexes, and that's bound safety. So of these top 13 things,
integer overflow, I didn't know that it's that big of an issue.
Like SQL injection or go sanitize your data, duh. You know, what can a programming language do? 5 of these top 13 things are things that a programming language could do, and they're the same things year after year in different proportions. But it's lifetime, excuse me, initialization, type, and bound safety. And let's just turn off slides for a second and just talk, because a lot has happened here.
I mean, you are talking, and I can be bad,
and in the few years
before that, because I
how many of you, especially
stream you, not otherwise,
based, how many of you have personally or had your work impacted? You've had to do work or something about your work has changed because of last year's executive order on cybersecurity in the United States. How many of you? Okay, quite a few hands. So for those of you who don't live in the States or who haven't been affected yet, on May 8th of last year, President Joe Biden issued an executive order on cybersecurity. The reason he did it, the reason that cybersecurity started getting political,
I didn't know about
executive attention, is because you'll remember all those ransomware attacks, all those cyber attacks on election infrastructure, on ransomware,
that's
on
good.
oil pipelines.
You know, seeing that people in charge are trying to do something with that.
And so a lot of folks on my team at Microsoft, maybe on many of yours, and those people who've raised their hands, have been spent the last year on supply chain security, have been spent the last year on programming language security. And part of what has come out of that executive order is it told the Department of Commerce and NIST, you got 60 days, give us your recommendations for making software secure. How many of you are aware that that happened last year? Department of Commerce. Let me tell you
so
what
probably that's why NSA
in July of 2021
produced the paper that I mentioned in the beginning.
So like not some little office. The Department of Commerce issued guidance that in response to this executive order, and this is a direct quote, that said, some programming languages such as C and C++ are not memory safe.
Okay, so we are probably talking about the same.
Those two. That was a direct quote. Subprogramming languages such as C and C++ are not memory safe. 2 sentences later, direct quote again, where possible, do not use memory unsafe languages. This is the first time a government has actually issued guidance to industry broadly, this was a year ago, that was the barest paraphrase away from where possible, don't use C and C++. And this year they're doubling down on it by funding projects to rewrite existing infrastructure and low-level projects in other languages.
Okay.
So when we talk about things like this,
thankfully they are aware about the
took a few minutes
issue, and
this,
it's
is because, you know, some of us are kind of jaded. We've been seeing these vulnerabilities since the 90s, since the 2000s.
okay.
And we've been skating by.
That's true.
You know, we added some smart pointers, we added some static analysis rules, but we've been skating by. But this is not the 1990s anymore. This is not the aughts anymore. This is a world where your software is under attack. My software is under attack, especially in the last 3 or 4 years. And if it's not under attack right now as this talk is happening, it'll be under attack tomorrow. And if you think that it doesn't affect you because you're an embedded system that runs in a refrigerator, oh my goodness.
No,
because those
be
are
aware.
I'm most concerned about. Those internet-connected appliances that don't get serviced. And where vulnerabilities don't get patched.
All of the smart fridges.
But when a government department starts telling you to do work and move to other languages, we should start to listen.
Yes.
So in that context, here's why I care about safety. What do we do about safety now in C++? So in CPP2, as always, static enforcement by default, safety by construction. You saw that in the example of s:= new string. Unique pointer by default, you can't leak it. And then sometimes dynamic enforcement where you need to, but we want to make it visible and pay for what you use. That's very important to us as C++ developers. And as you've already seen in some of the error messages I've given, I want CPP2's, CPP front's error messages to be of the form, oh, we're going to enforce that rule that we already teach by default. When you violate it, we'll tell you to do the thing we already teach you to do instead, like don't use union, use stood variant instead. That's an exact message from CPP front. And
great. First, take the best practices we already teach and promote them, and enforce them by default. Direct programmers to what we already say to do not this, do this instead. Okay, that's fair. That's if that's how would C++ evolve. Okay, I think I wonder if it would tackle all the problems regarding C compatibility. That would be really interesting.
And if we need to close any gaps, we'll do that. But mostly enforce them by default, enforce our rules we already have by default, teach people to do instead what we already teach them to do, and that's how we make sure that we're staying C++. That's my goal and my hope if this experiment can succeed. So let's talk about type safety. If you look in the C++ core guidelines, here is the full type safety profile, or set of rules. You'll notice I've tagged most of them with as. So last year here at CppCon, I gave a talk on pattern matching using is and as, which is mostly about is and as. And basically in CPP2, all casts are done through as, exactly as I showed last year. And it turns out that covers most of these rules, and I implement the other ones as well, except the one about classes, because I don't have classes yet. So here's that slide I showed you last year. The takeaway, for type queries, instead of all these spellings, just say is. For type casts, instead of these divergent spellings, just say as. And let's see it working.
Okay, hit me.
So for type safety, here is the first example I want to show you. And let's put that here.
When did you copy that?
So what I have is I have a generic function. It's a test function, but it's generic, so I'm emphasizing that. And it will print out the type ID, because I still have C++ type ID, if I want it, to print out the name of the type that I was actually given. And then I have an inspect expression. No, I have not implemented full pattern matching. I haven't done decomposition and stuff. I've just barely started writing inspect instructions. But this works today. So I'm going to inspect x, the thing I was given, and I'm going to, the value of the inspect expression will be a string. So if x is int, then the value of the inspect expression will be stood to string x as int. If it's a string, I'll print x as stood string. Otherwise, if it is wildcard, I'll say not an int or a string. So is it an int? Is it a string? Is it something else? But notice this is a generic function. I wrote it once. And I can call it with variant, any, optional, with
yeah, for that kind of function, it's really short.
Types, and it works. And I really emphasize, go back to last year's talk video. There's a whole couple of slides with a big dragon saying why divergent syntaxes are non-generic.
Big dragon.
I couldn't write this function if I couldn't spell all casts and all type queries as, and is. That's so important for generic code. So let's see what we've got here. We've got a variant of int double. And again, these are just the standard library variants that we have in our standard library today. And I'll set it to be a double initially. Then I have an any. Remember any? And it's going to be xzzy as stood string. So it's going to store a stood string. And then I'll have an optional int, which is currently, initially, doesn't have a value. So when I print test generic 3.14, that should say not an int or a string, right? V, it contains a double value, so that should say not an int or a string. A should say a string, right? X, Y, Z, Z, Y. And then for O, it should say not an int or a string because it's an optional int, but it's currently very optional. It's currently empty. There's nothing there. But then if I go and assign ints to each of these, then all of these should say true, 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 int, 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 int. Make sense? This is dynamic typing we already have in C++, but I hope nicer. So let's try this out. And Ubuntu seems to have closed its own window. I was waiting to see if it would finally come back, and it's actually just gone away. Let me just try it one more time, because I really, really do want to show a GCC,
okay.
if I can.
Ubuntu is revolting.
Huh, must have gotten an update. Ubuntu just does not want to work today. Very strange.
Not only
Maybe I'll post
now.
a video with the Ubuntu demos, and you can try them yourself.
I will. Definitely
So
I will.
let's go CPP front, and oh, that's pure, so I better go -pure because I don't want to import anything or include anything. CPP2 -p, and there we go. So I'm doing all my dynamic typing using the existing types I have for that in the standard library. This is just using the standard library types directly. So notice the code I'm generating here. Here is the main function that's just, it looks almost the same. It's just in syntax 1 that's doing all those same things. Notice the as becomes a CPP2 : as, but it looks very much the same. And here's that generic function, and you'll notice the inspect statement is a lambda that I introduce, I emit a lambda that I invoke right away. And if you say, oh, that looks simple, look at the scroll bar down here. This is the place where I generate the most code yet in CPP front.
Show it.
You probably want to see it, don't you?
Yes.
Okay, here's what happens when you Alt-Z line wrap. If const expr for the win. Let's just look at that. Actually, but you know what? It's not that I want to look at this instead. I want to look at this.
Wasn't expecting that.
And let the rest be an implementation detail. That's the world I want to live in.
I wonder if it
By the way, while we're
would be
talking about
written in the, CPP in mind. We could probably we could simplify it because I expect it's just because of the operation he makes in his this array interpreter. It looks like this, and it could be easily simplified. But I assume it still would be much more robust code than this block here.
type safety, Let me show you that thing that I mentioned. Like, let's say we want to define a union. What happens if we try to compile that now? Don't union, go variant. And that's the way that C++ should be, and I hope that it can be. And that's my experiment for type safety. Here are the screenshots. And now let's talk about bound safety. Bound safety, here is the bound safety profile again. I'm just taking what's in the C++ core guidelines and implementing it, making it the default. And I haven't done the fourth one yet, which would require me to actually check and have knowledge of the standard library functions that are being called. But I think I can do that one too, but I haven't done it yet.
Yeah, I want to live in
let's say we
the future where we are not using pointer arithmetic.
Don't do pointer arithmetic. Why can't we just enforce that today?
Enforce that, please.
Including it would break all the C code that we have.
What a pity.
So what I do instead is in syntax 2 code, which doesn't exist today, so I don't have to worry about breaking anyone, I just reject pointer arithmetic, including subscript. And while I'm at it, I just thought, those bitwise operators compile. Why? And so I eliminated those two. Did you know you could do a bitwise XOR on a unary XOR on a complement on a raw pointer? Now you know it, you didn't hear it from me.
Don't do that. That sounds like...
You know, it's one of those things where as soon as you start the sentence, now you're committed and you have to finish it. But you wish you hadn't started saying it, so I apologize for that.
Oh no. That's scary.
So let's look at bounds safety. So for bounds safety, here is a demo that we can start with. Here is this is all CPP2 again, just because I'm lazy and I don't want to include or import anything. And so I have words is a vector of strings with some strings in it. Now notice what I'm going to try to do. First equal is a pointer to std string that's set to words.front's address. Last is a pointer to std string set to words.back's address. Remember, most operators are suffix. Unary operators are suffix in CPP2. And those will compile. Where you get in trouble is where you do this old style loop where you decide, I'm going to use pointer iteration, ha ha ha, because I know I can. At least it's always worked for me for 40 years. And it was good enough for Kernahan and Ritchie, it's good enough for me, so I'll do first plus plus. But of course, we know that's unsafe. We get a lot of reported vulnerabilities from code like this. And I know that 9 times out of 10 you get it right, but 1 time out of 10 is way too much. 1 time out of 100 is way too much to get it wrong. Because if you get it wrong, your program compiles, no warnings, and appears to run. That's not the world I want to live in. And so let's try running. So the first thing CPP front says, error. No, please don't plus a pointer. Use std span or GSL span instead.
Oh, I thought this my cursor is drifting.
Enforced by default the rule we already teach. I'm not inventing anything here. This is in the core guidelines today.
Yeah.
And tell people what to do instead, which is the thing we already teach them to do today. That's in the core guidelines today as well. In fact, GSL...
I think I used to work on project where this information, and it was by Clank Tidy? No, Tidy is for fixing the code structures. Format. Yeah, I wasn't working in modern C++ for a time, so yeah, I want to remember how to was doing all the cool stuff with C++, because it was time. Because there was time I felt quite confident in my C++ skills, but it's not now.
Span is from the core guidelines. And the only reason, by the way, that I mentioned a non-standard thing there's 2 non-standard things that my error messages will recommend. One is GSL span, and the other one is GSL narrow. And the only reason I recommend those non-standard things is because they're not yet standard. So we have std span, and the only difference between GSL span and std span is that GSL span is guaranteed to do bounds checking. That's the only difference. Once the committee standardized it, we changed GSL span to snap to exactly that interface. And if the committee had mandated bounds checking, we would have gotten rid of GSL span. But it didn't, and so we kept GSL span, but the only delta is that it's bounds checked always.
Okay.
So what else could we do? Well, just to show you that you get error messages on these other ones as well, let me uncomment them, because there's different ways to do math on pointers, and yes, I don't like any of them, including that for tilde, pointer bitwise manipulation is illegal. Use std bitcast if you must. There's a way to spell it in your code. It's already in the standard library. Do that. While we're at it, this doesn't really fit under bounds safety, but while we're talking about pointers, this is just a convenient place to say, oh, why don't we just go delete something? And if you try to do that, I don't like these other error messages, so ignore them. That's just because I don't bail out of errors fast enough. That's on my to-do
that's
list.
dope.
The main error is delete and owning raw pointers they don't exist in CppP2. You just can't do that. Use unique.new, shared.new, or gc.new instead in that order. I'll mention gc.new at the end. That's not implemented here.
Okay, that's interesting.
All right, so
I
what
think,
should we do
yeah,
instead?
it's probably a garbage collector, but I wanted
The thing that we
to
teach people to do is
hear how it
use
works.
std span. That's what the error message just said. So let's do that. So S is a std span that we don't have to say of string because CTAD. S is a std span on words. And while I is less than s.si, see how it grows on you? Next I++. By the way, when I refactored the loops, all of them can have a next. So that's part of the refactoring. So I refactored that. So for, do, while, each can have a next phrase. That's what that is. Then I just go through and I print and decorate each one.
I don't know if I'm a fan of the syntax, but
we'll be fine.
Probably better what we get now.
So there we go. Now, I was going to stop the demo here, but when I talked to Joe Bialik, who I think was a speaker here also this week, one of our security experts who loves GSL span and is deploying it across Windows, one of the things he mentioned to me is, so about 4 years ago, Joe and I sat down, and we spent like a day, something like that. He spent more time, I only spent about a day. And we actually went through the last year's worth, I think it was a full year, of bounds safety security vulnerability reports where we had the source code that we could look at legally, especially our Windows source code. And we looked through it and looked at what are the root causes for each of them. And in that particular data set, it's not always going to turn out like this, but in that particular data set, Joe and I found every single one would have been caught if you'd just been using a bounds checked span. So that's not always going to be the case, but bounds safety is the easiest of these 4 safeties. Like just use span gets you like 99% of the way to full bounds safety in C++ if the span is bounds checked.
Okay.
But as I was checking,
I can say I ever did that, but yeah, I need to put
he said, yeah, that's
more
true, but
focus on that next time I will be right.
It's really a little hokey because about 2/3 of the time, like here, you have a container in scope, and all you do is you create this kind of artificial looking extra variable span just to iterate over it, just to satisfy the static analyzer. Wouldn't it be nice if the container itself, its subscript, were bounds checked? And I had to admit, I had kind of thought that too. It is a little hokey that we teach people you have to have this extra variable just to get the safety. But the safety is worth it. But that made me think. And so it's as a result of that I think a couple of weeks ago, you can check the commit log on CPP front. I forget when it was. I think it was like 2-3 weeks ago. I thought, well, what if we actually did the bounds checking on the original containers? But I can't change the original containers. I want to use the standard library. So when I say seamless interop, no thunking, no wrapping, no marshalling, just direct calls, that's C++. So I'm certainly not going to do anything crazy like wrap the standard library or wrap std vector.
Yeah, that will be really a hardcore way.
I have a compiler. I think I know how to do this. So let me show you. If I say, just put in, let me just put in a print and decorate the third word, right? How many of you see the bug? Oh, okay, more hands are going up. Good.
There is no.
You scared me at first. Of course, I kind of took you by surprise.
There is no word with associated.
This is not the third word, it's the fourth word.
Yeah, that's what I wanted to say.
Not so good. So what happens?
We are out of the bounds.
Compile this. I know the reaction I'm going to get from the first one. Wait for it.
Laptop will explode.
All CPP2 passes safety checks.
Can't be.
It's not so safe as you were saying, Herb. Demo.
Boom.
Falls over. Okay, good. I get my DOS back. DOS command line box back. That's good. That did not do what I think what I wanted it to do, right? What that actually did was access out of bounds, but I happened to get away with it and not crash that particular time. But if you were noticing earlier when I showed you the CPP front command line options, one of them was subscript checks. Enable subscript bound safety contract checks.
Okay.
What would happen if I compiled this same thing, but also with -s? Once the virus scanner decides the executable is okay. That's better. And see, it's not always that slow. Bound safety violation, out of bounds access attempt detected. But if you scroll up here, one other thing in this group of switches is add source info. I happen to know that that's supported in Visual C++. I don't think GCC has that yet. So I think I faked it.
Couldn't we put that in compile
does nothing in GCC.
process instead of runtime?
If I add PSA, like public service announcement, that's a total accident. And now I run it. Demo.cpp2, line 5, in function main, bound safety violation. Notice that's in my CPP2 source. I just used a vector of string, no wrapping, and it told me exactly where my out-of-bounds access was for vector subscript, and I put this under a switch so I could opt into it, but for my code, I'm going to turn that on all the time. And if you're wondering how that works, just look over here in the generated code. What it does is it wraps in a CPP2 assert in bounds any subscript operation, so here, like subscript word sub3, where the argument
that's smart.
is integral type, and the thing being subscripted has a dot size function. This will work on vector, array, string.
Okay, that's a really clever way of approaching that.
Size automatically with just a switch.
Okay, I assume it can be done.
By the way, one of the things you'll notice
compile
here
moment,
is if you looked inside the implementation of a certain bounds, what
we
it
don't
does
know
is
how
it calls a function called
what will be size of the vector before.
Dot expects.
Yeah, we can in this situation, but
too, optionally.
hardly
The way
in
that works is I've also implemented contracts.
Before.
A contract.
Yeah, you know what I mean.
Similar in line to what SG21 is doing in CPP2, just because I wanted to be able to write in contracts pre and post conditions and assertions, and I'll be happy to make that follow whatever SG21 does. But the way I've built it and the way that I've proposed also for the GSL expects and ensures is that every contract group is a named object. So there's one type contract group which has an expects function on it. And then you make an object of that type, and I give you, I think, 4 or 5 of them. There's one called type, so type expects, bounds.
Maybe do a quick break, or even a little bit longer break. I want to go to shop to buy something because I'm out of luck regarding snacks, and I'll get back as soon as I can. So I'm back. I bought myself a bar of chocolate and something to drink. But I already ate most of the chocolate on my way back. Okay, let's continue.
Is do different handling for different categories of errors. There's a reason I did this. So again, talking with Joe Bialik, one of the reasons is as we talk to different customers, including Windows, but also including others, one of their requirements is that certain errors, like bounds errors, have to be checked all the time. Like there is no turning those off. But contracts can be used for other things. They can be used for business logic, and they don't want those contracts turned on all the time. So you have to have some granularity. So the way I just chose to do it was to have a single contract group type, and then you just make a variable for every contract group. That's how you give things a name in C++. So if you want to, and each one also has a set handler, just like set terminate handler, that you can hook to get the messages yourself. So let's do that. Let's say that you have your own framework for handling contract failures already, because many of us do. And I'm going to just say, let's say you have so here's this function, it takes a message, and I'm just going to print to the console, but this could do whatever you do to call your framework, right? This is the hook function, and you can make it do whatever you want. All I need to do is to install the handler is in one place in main, is go cpp2 bounds, that's that variable, that contract group, set handler, call my framework, its address. And then when you do that, once the virus scanner decides demo.exe is okay, there you go. See, we'll do it again just to show that it's faster the second time. There you go. So now you've hooked that error. So now what have I done? What have I accomplished? I have bounds checking for all standard types that have a dot size, vector, string, array, all the containers that are indexable with an integral subscript can now be bounds checked automatically without wrapping them, without changing them. And you can hook that to do what you want with that bounds check violation if you don't like the default.
Because I was
a certain complaint.
Because I was wondering was the reason, but
So
that's really cool too.
Of the bounds safety work that I've been doing.
Because I'm mostly doing the very same
so you can see them in the handouts that
Python project because there is already implemented.
Just so you have them for your notes. And there's that handler we just talked about. Now let's talk about lifetime safety. We have a lifetime safety profile in the core guidelines. It is a static analysis. I have not implemented that in CPP front. But I've implemented just a little bit, and a little bit is the part about null pointers. My experiment within an experiment here is, do we really need null pointers? What if there weren't any? Or at least no pointers you could set to null in CPP2 because you can still get a null pointer from CPP1, so we can still deal with that. Well, we can't do that today because it would break the world.
Okay.
In fact, null...
Assume because you are asking this question, it's possible.
And it's the default value. Life is just so hard sometimes. And that always makes me think of Kate Gregory's wonderful talk.
Okay, that's again something that I needed to process in my mind to understand. Yeah, quite funny.
It's not a local pointer when it's uninitialized, which is even worse. You get a null pointer, which you can't actually dereference. And that doesn't seem kind of nice. So here's what I'm trying instead. Let's say that we have the same words vector string example, and I'm going to try to make P a pointer to string that's a null pointer. So let's see what happens. Error, pointer cannot be initialized to null or int. So, oh, you mean you can't, you won't let me initialize it to null pointer? I know how to sneak that one past you. I'll do 0 because I'm a C++ programmer and I know this trick. Yeah, the compiler knows this trick too because I know it. And 42 doesn't work.
You are smarter.
Oh, you know what else?
Okay, I wanted to say the best of yours, but you are the same.
Come on, admit it. Some of you were thinking that. That one gives a different error message.
Yeah?
You can't even say null anywhere in CPP.
Okay.
That's not because it's pointer initialization.
I simply would
it's a bad word.
abandon using that when and use null pointer
That's how
everywhere.
I feel anyway, I may be opinionated.
Okay.
So what should we do instead? Well,
Cry.
this gets into initialization.
Stop writing in C++.
So it's about lifetime safety and about initialization.
Becoming lumberjack.
But let's start with lifetime and pointers. So here's the same example, except I'm not initializing. Notice this is an uninitialized variable. Now that might sound scary, but it's okay, because CPP2 guarantees initialization before use. I let you make any local variable uninitialized. In fact, that's the default. If you say P is a pointer to
I wonder what
string,
it is in standard in C++.
there's no equals value. It's like, okay, I'll just allocate space for it. And I'll wait
Probably
till
due to the compatibility.
So if we don't initialize it, local variable P is used before it was initialized. Line 4, program violates initialization safety guarantee. Okay, so line 14, yep, there's the initial. We try to dereference it, which is a use, an important use, before it's initialized. Okay, so let's initialize it. Let's initialize it. If stood rand mod 2, that's like flip a coin, we'll initialize it. How many are happy with that initialization? Pretty thorough, check it in, ship it? No?
Could be better, I assume. But
CPP front agrees with you, but now look what it said.
oh, it does it.
How many of you wish your compiler gave you that kind of error message today for uninitialized variables? Can I hear applaud if that's a compiler?
Okay, that's really cool that it checks in the compiling phase, not in the
reason I asked for
runtime.
applause was not ego, but so that I can see your hands, is so that the compiler implementers watching this video can hear you. Oh, is that what you said too, Dietmar? Oh, I stole his line and I didn't even know it. Okay, great minds think alike. I can hear the heckling from the front row. So let's actually go put back that else branch. And now, sometimes we'll initialize it to the first word, sometimes we'll initialize it to the last word. And so now if we compile that, now it says, okay, pass the safety checks, and on this particular run, it'll print the first word. Cool beans.
Great. Cool beans.
This is a good segue, and here again
To our
are
sponsor.
your screenshots of what we just saw. This is a good segue to initialization safety, because you'll notice the error I gave in most cases, besides the equals null pointer, was not about, hey, your pointer's null. It was a much more general error. It was you are using a variable that has not been initialized. And 2 years ago, I gave a talk that talked about parameter passing and initialization, because they really go together. And I made a big deal, rightly, I think, of Fred Brooks's distinction between essential and accidental complexity. You got to be able to say a function is virtual somehow, polymorphic somehow. That's an essential thing to say. The cumbersome way we sometimes have to spell that in C++ is not essential. It's just the ceremony we use in one particular design. And that means it's something that we can improve.
Wait, I want to read that.
So you might remember I went through the C++.
Essential complexity inherent in the problem presenting any solution. Accidental complexity, artificial of a specific solution design. Can say I understand it, but go on.
Improve or even remove. So you might remember I went through the C++ literature shown on the screen, and this took me many months. I have a big Excel spreadsheet with over 600 rows where I painstakingly catalog the rules, not just each item, but each particular piece of advice. It might be a paragraph, it might be a subheading. in Scott's books, in Andre's and my, High Integrity C++, Abseil, a few others, and painstakingly cataloged which ones were essential and accidental. So I told you that part 2 years ago. What I'll now tell you is, and I also cataloged which ones, I did this by saying which ones would be fixed by CPP2. That was my litmus test for, I called it accidental and improvable, or essential and improvable only if I had an answer, not because I was being a couch critic, an armchair quarterback. I said it was improvable.
That's
only
dope.
if
He
I thought I
played
had a
against
way to do it.
himself.
And two of the biggest categories were initialization safety and parameter passing. That was of that guidance literature corpus, it was nearly a quarter of all the rules that it taught, often because they're repeated. It turns out every book teaches parameter passing. We just have to say so much about it. So I also introduced the concepts of definite first and last use, which you're about to see. So remember, if I have a variable x, and you look at this function, look, there's the first use of x in line 1. That's a definite first use, because if on any path through this function, that's going to be the first use of x. You have two definite last uses of x, because if control flows through either one, it will never touch x again later in the function. So this is actually very simple to reason about. C# has this. I think Ada has something like this. All you do is look at the branch paths. Loops don't count. If you have a loop, you better have initialized, because loops are in some ways like an if, because you might not enter them, right? And y has no definite first use, but it has a definite last use. If you get to the end of the function, no exceptions thrown, so no return, that is the definite last use.
I wonder where we are going with it.
So that's just a refresher. That's pretty easy to think about, but we're now going to use those concepts. And I think these ones, oh yeah, here we go. We're going to use some of our familiar functions here. So here I have a function that has an x that is not initialized, and then I try to use it. So, oh, did I hit save? Can't tell you how many times why didn't the compiler check that? Oh, I have to save the file. I'm sure nobody here has ever done that before. Okay, so this is the same thing. It's not a pointer this time, it's a string. Local variable x is used before it was initialized, violates initialization safety guarantee. So great, let's uncomment our code. And these could be nested ifs, and it's the same rule recursively.
Okay, so we got two ways of initializing x.
It's a delightfully recursive rule once you think about it. It's like, oh yeah, that's the initialization safety rule. Save that, and now let's run this. Oh yeah, I have this problem with Microsoft. For some reason, module import of the current modules doesn't find time. Okay, I just discovered that a day or two ago. So that's okay, I'll just change this. This is where I really want to show GCC. Okay, I'll just change this to our good old
I think the
nice thing about showing it with time
Microsoft
is
compiler
that
is good as well.
The program, and every second the answer flips back and forth, so you can see both branches being exercised. But I can't use time with modules today, so sorry about that.
Oh, happens.
So now let's try this one more time.
You tried.
Now we're fine. And so when we run this, okay, it took the one branch. Which branch did it take? It took the branch that was the else in this case, so it filled it from plug. Now let's actually take a look at what's going on here, and you can watch in the generated code as well to see. Let me line it up so you can see them side by side. Oh, side by side would be like this. Here we go. So for a local variable that doesn't have an initializer, I create a CPP2 deferred init of that type. That just allocates storage, it's aligned, et cetera, correctly, and then it waits for a constructor. And then when you initialize it with equals, I turn that into a construct call. When you initialize it with a function call, which we sometimes need to do, you can fill it with an out parameter. Notice that there's an out parameter on the function. The semantics of an out parameter which is implemented as a CppC2 out of, in this case, string, is it can take an initialized or an uninitialized variable.
Okay.
So CppC2 out knows which it's constructed with. Is it constructed with
Okay.
a full value?
That's cool that this is explicitly said, and we can work around and inform programmer.
When you assign,
I like it.
it will call construct, which if the variable is already constructed, it will just assign to it. I want to just point out how cool this is for composable initialization safety, because how often do you put a buffer on the stack or a std array of bytes, and then you call a function, fill from database, memset, memcopy. And you don't have to put dead
happens quite often.
Into zero initialize a buffer with data that's only going to be overwritten immediately anyway. That's inefficient. Compilers are really bad at getting rid of those dead writes. This way we have one set of initialization rules for every type, for pointers, for strings, for ints, for big buffers, big pods. It's all the same rules, and they're composable through out parameters. And I'll just say, when you please take some time over the coming weeks, months, as you think about this in the back of your mind. When I have talked to people about parameter passing, it is very common for people to say, oh, I like all of what you're doing here, except I question the value of out parameters. And they're actually tied for the most important of all 6 of them. In and out are the most important. And here's one of the reasons why, is because they give you composable initialization. They give you initialization with program meaningful values guaranteed. No
wait. I want to hear it again.
Say, when you please take some time over the coming weeks, months, as you think about this in the back of your mind.
Okay, think about what? Because I think
initialize a buffer with data that's only going to be overwritten immediately anyway. That's inefficient. Compilers are really
putting zeros and rewriting is inefficient. Okay.
Bad at getting rid of those dead writes. This way we have one set of initialization rules for every type.
One set of initialization. Yeah, one set of initialization. Okay.
For pointers, for strings.
I mean, I understand with this construct.
For ints, for big
so far
buffers,
so good.
Big pods. It's all the same rules, and they're composable through out parameters. And
okay, I need probably check what composable means. Capable of being set to music. Okay, that's probably not that. Composability is a system design principle that deals with the inner relationship of components. A highly composable system provides components that can be selected and assembled various combinations to satisfy specific user requirements. Okay, so, you know, modularity, I think, or maybe not. I think it's quite related to modularity, I think. So we can, it's next step from that. So you can take few modules and combine them as needed. Okay.
I'll just say, when you please take some time over the coming weeks, months, as you think about this in the back of your mind. When I have talked to people about parameter passing, it is very common for people to say, oh, I like all of what you're doing here, except I question the value of out parameters. And they're actually tied for the most important of all 6 of them. In and out are the most important. And here's one of the reasons why, is because they give you composable initialization. They give you initialization with program meaningful values guaranteed.
Okay.
No dummy initialization, then I'll initialize it.
I get it. So we can explicitly say
this from sanitizers,
there is nothing, and we are going to initialize later.
Plus,
okay,
if you think about what this out parameter is doing, any function that has an out parameter can be a constructor. You're delegating construction in a safe way because it's guaranteed statically that it's going to happen dynamically to this function. So fill is in fact conceptually a constructor. We have generalized the concept
Okay.
of initialization to be composable. And I think that's a really cool and valuable thing. And
Yay!
And you this much more cleanly. And let's go back to mixed CPP1, CPP2 code. So I apologize, there are some includes here. You will have to look here. Let's scroll down so you don't have to look at them.
I can live with that.
What I'm going to do here is have a function. Here is f is a function that takes no parameters and returns what? Shout it out.
Returns it's nothing.
It returns an int named I and a string named s. How many of you have wished for years you could have this in C++?
Wait. Oh, okay, I get it. It's in his this interpreter compiler thing. Okay.
Bunch of hands. Okay.
Yeah, that would be
So
quite
what you do, this
great to
follows
have
the same-
multiple
the same initialization
without
rules. So if you
wrapping
let's actually
it
generate the code,
somehow.
you'll see it. Oh, not dash p. Ha ha ha. We're using the preprocessor. Sorry. There we go. Great.
He
So if
forgot.
you look at the generated code, I'm just going to go slightly smaller here. If you look at the generated code, what we're doing is we are generating a return struct for the return type. So this is a normal C++ struct decorated with an under. I'm going to count myself as an implementer, so I get to use under, which means that it is not littering your namespace, right? One of the problems with doing this yourself is you're littering your namespace because you can't actually define the return struct in the function declaration. You have to define it right before with a semicolon in between, and that litters your namespace. Well, I just generate it for you, and I don't litter your namespace because I double underbar it. And then, but here's the point I'm getting to.
Wait, what does mean? Double what?
Your namespace because I double underbar it.
Double underbar it. Double underbar it. Double underbar. Double in bar. Double bar meaning it's also related to musical composition. Double bar is just certain kinds of norms in math. I don't know, it's that. Ah! Okay. Because I thought it's some idiom or something, but it's underscore. Okay. Yeah. Moving forward.
And then, but here's the point I'm getting to. All I then do is create two local variables of exactly the same type you just saw. They're just ordinary local variables with those names. They follow all the rules that they construct on first assignment, and you get all the initialization guarantees that you must initialize before use on any path, including the use where you return and you automatically move from those values. Because I generate the student move, so you don't have to. All you do is you say, okay, I return two things. I is an int and s is a string. Oh, look, I construct I here, I construct s here or here. Then I do this other thing, which is not a constructor. That's okay too. I just use it. And if I forget to construct it, will tell me before I do this. And then I just say return. And I don't need anything before the semicolon because I already know the names I'm returning. They're in scope, I and s. And furthermore, if you look at the structured bindings here, oh, let me actually run the demo so you can see this. There. This is why this is mixed, because this is a CPP1. This is a today's main that uses today's structured bindings, and it just works. So I've got a function with multiple return values in CPP2. I call it from a CPP1 function, just works. And if I wanted to, I could even use the names if I wanted to, because the names are there. This is so much better than returning an anonymous tuple, or that you have to remember to write the struct yourself and not litter your namespace too bad.
I see that. I see that would be really.
So that's it for initialization safety.
That's used. Okay. So far, he shows really interesting things all around.
So here are the slide shots, the screenshots that we have from what we saw. Now let's talk briefly about more parameter passing, because you've already seen out parameters, so let's just look at the other 5 briefly. Here is a function that exercises all of them. In, which is the default, but I wrote it out anyway. It could be white space, just so you can see it. Copy, in, out, move, forward. And then, when I generate this code, here is what gets generated. So let's look at these things one at a time. An in parameter becomes a CPP2 : in of that type. This automatically makes it const. So there's no more, oh, if I pass t versus t const, or that's the same, except when it's not, none of that.
Okay.
There's also none of this, do I pass it by value or by reference to const? Because CPP2 in for trivial copyable types that are smaller than, that are 2 pointers or smaller, it'll pass by value, otherwise it'll pass by const reference. So that's just automated.
Yeah,
you
I
never
think
need to think about that
it's
again.
even great way to, if someone, because there is this ampersand, and yeah, is this and now this is moving, whatever. It's great to replace symbols with readable keywords. That's awesome. I love it.
V2, at least I don't, and I wrote this for myself. Copy is just takes a copy, as you can see at the top, but then I automatically move, notice, from definite last use if it's legal. So you'll notice that in the generated code, the first definite last use of B automatically got a move. The second one did not, because I'm taking its address. If I wrote std move there, it wouldn't compile in the C++ compiler, because that's illegal. Same for plus, minus, and a few others. So I'm smart enough to do that, because I learned that because I first emitted move and then it wouldn't compile, so then I went back and fixed it. In out is the easiest one. It's just as if passed by reference, but I'm declaring my intent. Move. Move also implicitly moves from last use. And at the call site, notice at the bottom, you opt in by saying move from that parameter in order to call the move, from that argument to call the move parameter. It generates std move, but you never need to say std move. In fact, it's illegal to say std move in CPP2. You say move only in these places on the left, which means I never again, I hope, have to teach why does std move not move? Well, it doesn't. Why do I?
Yeah, that's quite confusing for new people. Why?
So I don't have to teach
move
that. That's the kind of world
sometimes
I want
works,
to live in for my
sometimes
C++
it
code.
doesn't need to work, but you're
forward is
calling
interesting.
it anyway.
Notice that forward becomes an auto-ref parameter. Thank you, C++20. This would have been harder to write, this compiler emitting C++17. Could still do it, but it would be harder. It's an auto-ref parameter with a requires clause, that's C++ concepts, that says it's the same type as string. So the deduced type is string. You can do this today, but almost nobody does. This is how you forward a concrete type. Normally, perfect forwarding only works for template parameter types. You can do that too, but you can also forward concrete types easily, and then we automatically forward from definite last use, as you can see at the bottom.
Okay, I think I harder than.
There's one last thing. You might have noticed those symbols at the bottom. And I've talked about consistency in functions. There's one way to declare functions in CPP2. This is my experiment anyway. A named function just has a name in front of the colon. The exact same function can be written at expression scope as an argument to std ranges for each. We call it a lambda today, but I think of it as just a function expression. It's just still the same grammar. It goes through the same function in my parser. And a range for loop body is also a function, because that's the one place in the language with the semantics of that we invoke some code repeatedly with some arguments that change. So what a range for loop does. The syntax is the same. And if you've been hearing me all hour and a half long saying how the syntaxes are all the same, how many of you have wondered, yeah, but what about capture? Come on, it's okay. A few.
The thing I was
oversimplifying,
just
because you need
thinking
lambda
right now.
capture, right? Yeah, you do. But you don't necessarily need a different function declaration syntax to do it. And I have to credit Tim Sweeney with this. I was sitting with Tim Sweeney at his offices a few years ago talking about this. And he said, well, for Lambda, why don't you just always capture in the body? And by the way, always capture by value. If you want a pointer, take the address and capture that. And especially now that I have pointer safety and initialization safety, that made a lot of sense to me. So thank you, Tim. I took that one and ran with it. So I appreciate it. So this is how lambda capture looks. And it's only allowed inside expression functions, but it's the same grammar. It's just restricted outside expressions. If I want s's value, I capture it there, and then later when the lambda is invoked, I use the value. Can you think of any other place in current or currently proposed C++ that is like capture? That is kind of like this, where you capture something and then execute it later? Coroutines, that's a good one. Anything else?
Okay, yeah.
There's a few. The one I was thinking of is post conditions. So this code works in CPP2 today, the code at top. A post condition, you often want to look at the initial value. So I thought, well, the post condition, you write it at the top of the function, which is conceptually on enter, right?
Okay.
And you execute it when you leave the function, not through an exception, on return at the end or return in the middle. So what I'll do is that's capture. If I want to say for a push,
this about idea of post condition.
Push back one value.
Say later.
But the post condition is that the new collection size is the old collection size plus one. Well, I'll just capture the old collection size here. I'll say collection size capture, and then when the post condition is evaluated at the end, collection size equals that captured value plus one. Works great. And if you're familiar with other languages, there's one other place, which is string interpolation. All three of them, this code works today in CPP2. They all use the same syntax. And I think it's really important that there's one way to capture, there's one way to declare functions, there's one way to declare anything, because variables, types, and functions are all declared the same way. And then we can get on with writing the business logic that we want, that we get paid to do. So we've talked about all these things, and I want to make an observation here at the end. Think about the words and the ideas that we've been using for the last hour and a half. I have not said the word monad once.
Okay.
All of the words and the ideas that we have been using are not weird foreign terms from some other language, not weird foreign concepts from some other language. They are things we are deeply familiar with.
Okay. You know, like, yeah, but also because we are coming from them, and that's why we don't terms, because we translated it in different terms for our purposes. Not that we are some other.
They're how we talk. They're how we think. And I want that to stay that way, just nicer. I want all those same familiar things.
I think it's
just nicer.
Great idea to.
I still have lots of work to do. So
next
I actually have to write explicit parameter lists. This is an order.
Reps go.
Difficulty, by the way. I still got to do classes, including in my paper D708, you'll notice I propose unifying constructors and assignment throughout parameters. This is a huge unification. Maybe over Christmas I'll try implementing that and make sure it works out. But I think I'm most of the way there because I've already implemented out parameters. Reflection generation and meta classes using the parse tree, because I think that's the right level where you want to generate new things as if generating source code, but not just text. You're doing it in a disciplined way. And lightweight exceptions. That one's going to be, I'm going to see how far I can get. And I'm talking to some of the implementers about how I can implement that. That might be the hardest one. There might be something I can piggyback on, because you need to be involved in the unwinding logic. And then can we get the throw and the catch to be deterministic time? I'm optimistic, but that one will be the most work. But this is what's
reflection to
on my roadmap to implement next. So this is an experiment in progress. If you want to help, maybe in the medium term, here are some project ideas, and maybe you have other ones. If you do, please email me. Editor support. I took a look at doing syntax highlighting. Oh, that grammar is so hard. That's too hard for me. I actually emailed the author of one of VS Code's most popular, like the default C++ grammar, and said, how do I just highlight a couple more keywords and this regular expression? And he emailed me back saying, go to these discussion forums, it's really hard. This is the guy who implemented the one Microsoft is now using for C++ and Visual Code. So
you
if
know
you're
what?
a guru at that, you're smarter than I am about that.
That's a great answer. Oh, wait. Okay, I'm just joking, but yeah, yeah, you know, it's done somehow. Oh, there. Wait, because I think in the middle, well, I need to check.
Please email me to help. If you're interested in implementing, hey, we have universal function call syntax, what would autocomplete look like to find a non-member function when you say my object dot to find a non-member? Please send me mail. If you're interested in putting this on Godbolt, maybe being able to pick which compiler to use for the second compiler. If you are a garbage collection expert, so 6 years ago at this conference, I showed, and I still have on my GitHub, GCPP, a prototype garbage collected arena. In C++2, CPP2, everything is garbage, not everything is garbage collected, that would be terrible. All memory allocation is done in arenas. One of them should be a don't pay if you don't use it, but opt in and have it be available, garbage collected bubble of memory arena. I wrote a prototype implementation, but I am not a garbage collection expert, so it don't scale, but it's a proof of concept. If someone who knows what they're doing would like to collaborate, please send me mail. And I've done some work too, so I'm not just asking for a pony. CPP2 Draw. If you are interested in a basic drawing API with keyboard and text, basically a 21st century curses or conio.h, and especially if you can think of a way to make it header only, send me mail. And longer term, if you're interested in taking an existing major C++ compiler's pretty printer and emitting CPP2 code, so I call that front CPP, seemed like a reasonable name, send me mail. Because one of the things that could do is, in today's code, detect patterns and idioms that in CPP2 can be expressed directly and translate them. So that's a source migration tool.
Really interesting
that's a long-term project idea. But let me close with this. What if we could do C++ feels like a new language again, like we did in C++ 11? Feels like it, but it is still C++. But this time do it broadly across the whole language. This is an experiment that can fail. If somebody can find a better way to skin this cat, please do. I want to start a conversation to see if we can try it out, to see if we could get there. The idea would be to support, not compete with C++ evolution, embrace C++ 20, 23, 26, embrace the modules we have, make import std the default. Think of it, I do, as a directed evolution of C++ itself, and compiling to today's C++ keeps us honest. And then as we learn things, we can bring parts or the whole thing to ISO C++ because they own the language. That is what C++ is. So here are the major things that I talked about today. And just to put it in perspective,
Okay. I clearly need of the stream because microphone is really strange and I need to. Yeah, sorry. I don't know even if hearable what I'm saying right now. I'll quickly